In this video, you're going to build a real AI SaaS application that turns speech into text, just like a production product. By the end of this project, you'll have a fully working app where users can upload audio, generate transcripts, manage credits, and use it like a real business. We're not building a demo, we're building the full thing: authentication, payments, a protected dashboard, a real AI pipeline, and deployment to the internet. I'll walk you step by step from an empty project all the way to a live application you can actually use or even turn into your own SaaS. And once the core experience is in place, we'll power everything with a modern, production-ready stack. On the front end, we'll use the T3 stack with Next.js 16, TypeScript, the app router, and Tailwind CSS enhanced with Shad CN UI. For authentication and user management, we'll integrate Better Auth and Better Auth UI to handle sessions, protected routes, and account flows. On the backend and database side, we'll use Prisma with PostgreSQL on Neon to manage users' transcripts, credits, and application data. For the business layer, we'll build a full credit system and payment flow using Polar, including checkout, webhooks, and a customer portal. And for the AI pipeline, we'll build a real Python backend with Fast API and Pydantic, deploy it to Modal on GPU infrastructure, and power transcription using PyTorch, Hugging Face transformers, and Cohere's Transcribe model. Finally, we'll connect everything together, push the project to GitHub, and deploy it on Vercel so it's fully live. And if you're new here, I'm Sahand, a full-stack developer with over 16 years of experience, a PhD in engineering, and I've taught hundreds of thousands of students how to build real-world applications. If you want to learn how to build real-world AI SaaS products with a modern production-grade stack, this is for you. Without wasting any time, let's jump straight into it and start by installing Next.js. Welcome back to this step of the tutorial. In this section, we will install Next.js and Tailwind CSS. We will also create our very first project template. I have already created the final version of this website. It is live and deployed. You can check it out yourself. Just visit it using this address. You can create a free account and explore the app. Try the speech-to-text feature and see how it works. To keep things simple, we will use the T3 stack helper. This tool takes care of the whole setup. It installs everything we need. Let me open the official T3 stack site on my screen. You can open your browser and search for T3 stack on Google. The official website should appear as the first search result. The T3 stack gives you a strong base for your project. It creates a fresh Next.js app. It also comes with TypeScript setup. This means your code is type safe right from the start. We just need to run the command shown on their website. We can copy that command, paste it straight into the terminal. First, we will create our new project folder. Let us create a new folder for our application. Let us open Visual Studio Code together. I will open the File menu. From there, I will choose Open Folder. I will make a new project folder right here in this location. This folder will hold our entire project. I am going to call this folder AI Speech-to-Text App. This folder will be our main workspace. Let us open the terminal together. We will grab the command from the T3 stack website. We will use npm here. It will run the installation command for us. Head back into Visual Studio Code. Paste the command into the terminal there. To keep things organized, I will add a new folder. I will call this folder frontend. This command will kick off the setup. It will install everything we need. During the setup, the tool will ask you a few questions. Your first choice is the language. You can pick TypeScript or JavaScript. In this case, we will choose TypeScript. It fits this project well. Next, we will pick Tailwind CSS. This will handle all our styling. This option also includes a starter example website. It looks like a simple blog post app. We pick the No option here. This helps us avoid creating extra files. For the authentication setting, we will choose the option labeled None. This choice gives us full control. We will build our own authentication system later. T3 Stack also lets us pick our database tool. We can use Prisma or Drizzle. We will go with Prisma here. It will handle our database for this project. For our page navigation, we will use the App Router feature. This approach is the recommended choice. It is how most modern Next.js apps are built. Our database provider will be PostgreSQL. We will also add ESLint and Prettier. These tools help keep our code clean and consistent. These tools will keep our code clean. They will also check for common mistakes. The T3 setup asks if we want a GitHub repository. At this step, choose the option for not creating a repository. We already have a separate front-end folder. Creating a repository here would limit it to that folder only. We want one GitHub repository for the whole project. It will include both the front end and the back end. We will skip this option for the moment. Next, the T3 Stack tool asks about automatic installation of dependencies. It might install an older Next.js version. We want to use the newest release. In this case, we will choose No. We will update it ourselves a bit later. We will also turn on import aliases. This helps us use cleaner and shorter paths. At this stage, the T3 Stack setup has finished successfully. Our project folder structure is ready and fully set up. You can also see a Prisma folder. It contains the main schema file. There's also a public folder. It holds static files like images and icons. You will find the main source code inside the src folder. The front end is split across several folders and files. The src directory controls all pages and routes. Inside the app folder, you can spot several important files. The home page lives in the page tsx file. It sits right at the root of the app directory. We will also add 2 dedicated folders for the dashboard and authentication later. Let us switch over and inspect the package JSON file together. This file lists every tool the project depends on. It also defines handy scripts you can run. When we check the project setup, we see it uses Next.js 15. However, the newest release is version 16. I will upgrade our project to use it. At the time of this recording, the latest release is version 16.2.3. After updating to this version, we can move into the front-end directory. From that folder, run npm install. This will install all required packages. This command will download every needed package. It will install all project dependencies listed in the package JSON file. You can see that the install has finished. All required packages are in place and ready to use. Let us start the application. We will check that everything runs correctly. We can now run the command npm run dev. This will start the development server. In the terminal, you can see that Next.js is version 16. The development server starts without any issues. It is running locally on port 3000. You can open it in your browser. Just click the link shown in the terminal. The T3 Stack tool has created our starting project template. We will clear out this default content. First, drag the browser window to the right side of your screen. Place Visual Studio Code on the left side. Next, open the home page file inside the app folder. The file is named page.tsx in this directory. Delete every piece of default content from this file. This gives us a clean, empty page to build. After that, create a React functional component using the RFC snippet. Name this new function homepage. Next, we will add a small test. This will confirm that Tailwind CSS works correctly. We will add a Tailwind class to our text. This will change its color. For example, we can change the text color to bright red. This simple change confirms that Tailwind CSS is installed and working correctly. In this step, I will share my favorite Visual Studio Code extensions. The Auto Rename Tag extension keeps your tags in sync. It updates both the opening tag and the closing tag automatically. Another essential extension gives you React and Redux snippets. These help you write code much faster. For example, I used one of these snippets. It created the React functional component for me. Multiple cursor case preserve keeps your text casing consistent. Prettier takes care of formatting your code for you. The Prisma extension is very helpful. It keeps your Prisma schema files clean and well formatted. I have also added Python extensions. These will help with back-end work later in the project. You can pause the video here. Search for these extensions in the marketplace. Install any that you find useful. Another extension I strongly suggest is Tailwind CSS IntelliSense. It automatically suggests Tailwind utility classes while you type. That wraps up the Visual Studio Code extensions for this project. Now that our extensions are set up, let's create a GitHub repository for this project. First, stop the development server. After that, clear the terminal window. Move back to the main project folder in your terminal. Up next, we will create a new folder for the backend. This helps confirm that our project structure is set up correctly. Inside this new folder, create a simple test file. It will act as a temporary placeholder. This file is a small step, but it is very important. It makes both folders appear in the GitHub repo. This confirms our project structure. After you finish that step, move back to the main project folder. Confirm you are in the correct directory. Initialize a new Git repository by running git init. This command creates the Git folder. It adds all the files needed for version control. At this stage, your Git repository is set up. It is ready to track every change. Before we add any files, fix one thing inside the front-end folder. During the installation, an extra folder was created. It is called generated. We will delete this extra folder. It is not needed right now. The Prisma client will be created later. It will generate after we set up the database and authentication. At that stage, it is safe to create this folder again. Next, stage all project files and folders with Git. After that, create your first commit. Use a clear message like install Next.js and Tailwind CSS. Commit all these changes to your local repository first. After that step, we will create the main repository on GitHub. Open your web browser and head over to github.com. Make sure you are logged into your GitHub account. One big advantage of GitHub is that it is free to use. You can create as many repositories as you need. Click the plus icon in the upper right. Choose New Repository from the menu. Let us set up a fresh repository for this project on GitHub. We will name this repository AI Speech-to-Text App. Add a short description such as AI Speech-to-Text SaaS app using Next.js, Tailwind CSS, Neon, Polar, and Modal. I will set this repository to public for easy access. You can choose public or private for your own repository. Next, copy the 3 GitHub commands for pushing your project up. Switch back to Visual Studio Code. Paste those copied commands into the terminal. This will send your whole project to your GitHub repository. When the commands finish running, refresh your GitHub repository page. You should see both the front-end and back-end folders there. If you run into any problems, open the GitHub repo. You can review the commit history there. There you can see every change I made. Use it to compare your code with mine. You can also copy and paste specific parts. Use this method if it feels easier. I will also add a link to the final deployed site. you can open it directly from the repository page. This wraps up installing Next.js and Tailwind CSS with the T3 stack. Up next, we will set up our authentication system. This will handle user sign in and sign out. This step is a key part of our project. We will set up user accounts. Users will be able to sign up. They will also be able to log in. All right, see you in the next section. We're now starting the authentication part of the project. For authentication, we'll use BetterAuth. Open your browser and search for the BetterAuth website. BetterAuth is one of the most complete authentication frameworks available. It is designed for TypeScript developers. It gives you everything for user management. You get sign up, sign in, and reliable session handling. A major advantage is that it's completely free and supports all common authentication methods. Setting up BetterAuth requires a bit more initial configuration, as some components need to be set up manually. In return, you get full access to powerful features at no cost. To begin, open the documentation and navigate to the installation section. Copy the installation command shown there, head back to Visual Studio Code, and open a new terminal. Make sure you are inside the front-end directory. Paste the command you copied into the terminal. Press Enter to start the installation process. The package has been installed successfully, so we can move on to the next step. Now we need to set up our environment variables. We need to add two important variables. The first is the BetterAuth secret key, and the second is the BetterAuth URL. Click the Generate Secret button to create a secure key. Copy the full generated value and paste it into your environment file. I'll also add these variables to the example environment file. This file will be pushed to GitHub while the real environment file will be ignored by Git. This allows you to see the required structure without exposing any sensitive data. In the example file, I'll replace the real secret with a placeholder value to keep the actual key secure. Next, go back to the BetterAuth documentation and locate the BetterAuth URL. Copy it and paste it into the environment file as well. The next step is to define the variable types. We will set these up inside the env.js file. First, define the BetterAuth secret as a string, then define the BetterAuth URL also as a string formatted as a valid URL. Now we need to move to the runtime environment. We have to add these new environment variables there as well. We set the BetterAuth secret using process env, and we also define the BetterAuth URL variable in the same way. This type safety helps protect our environment variables. It ensures each value uses the correct data type. For example, you can't accidentally use a number where a string is required. This prevents common errors early and makes the application more reliable. Our next task is to create a BetterAuth instance. This step is outlined in the documentation and is responsible for handling all authentication logic in our application. To do this, we need a configuration file for BetterAuth. We'll name this file auth.ts. It will live inside a new folder called lib. Now let's create them in our project. Head back to Visual Studio Code and navigate into the src folder. Next, create a new folder called lib. Inside this folder, create a new file named auth.ts. Now let's return to the BetterAuth documentation. You'll find a dedicated section for Prisma integration. We can copy the provided code directly from there and paste it into our new authentication file. We need to import the Prisma client. This import should come from a Prisma client. Before continuing with the setup, let's visit the Neon website. We need to retrieve our unique database connection URL. You can access Neon using the link provided in the resources section. Neon is a serverless Postgres database built for modern web applications. It scales automatically, making it a great choice for Next.js apps deployed on Vercel. The setup ensures fast and reliable database connections with smooth performance. Neon also allows you to instantly branch your database. This makes it easy to test new features without affecting production data. It integrates seamlessly with tools like Prisma and Drizzle, keeping database setup simple and efficient. One of the biggest advantages of Neon is its generous free tier. You can start using it at no cost and create up to 10 separate projects, which is more than enough for development and testing. Let's create a new project for our application. For the project name, I'll use AI Speech to Text App. Click the Connect button. This will provide a database connection string. Copy this value and paste it into your environment variables file. Next, we need to update the Prisma file. Inside the Prisma file, first update the client generator by removing the output field from this section. After that, click Generate DB to generate the database client. Now, define the name of the new migration. I'll simply name it first. If we go back to Neon and navigate to the table section, we should see that the post table has been added. This matches what we defined in the Prisma schema. We currently have a post model, but this was created by the T3 stack by default. We want to update this model to work with Better Auth. Next, go back to the Better Auth website. Copy the command needed to create the database for user authentication. Return to Visual Studio Code and paste it into the terminal. When prompted to overwrite the schema, type Y. This updates the schema file with the new configuration. Now you'll see that the user, session, account, and verification models have been added to the schema. The only table we still need to create is the transcript table. This will include fields like ID, name, and others. We don't need the post model, so we can delete it. Inside the user model, add a credits field. This will be an integer with a default value of 10, giving each user 10 credits when first created. Next, add the transcript model. This includes all fields needed to create transcript, such as file name, user, and more. Before generating the database, we need to connect the transcript model to the user model. Add a relation inside the user model so each user can have multiple transcript projects. This links each user to their transcript projects. After adding this relation, click Generate DB again to update the database. Our database is now fully synced with the updated schema. Go back to Neon and refresh the tables view. You should now see the new tables, including the transcript table. Next, we need to configure an authentication method. This step is in the Better Auth documentation. For this project, we'll use email and password authentication. Copy the authentication configuration code from the documentation. Return to Visual Studio Code and paste it into the auth.ts file. Next, we need to set up the mount handler. This ensures our authentication system can handle incoming API requests correctly. Since we're using Next.js, select the Next.js tab in the Better Auth documentation as a reference. we need to create a file named route.ts inside the API directory of our application. First, create a new directory called API inside the main app folder. Inside API, create a folder named Auth and a subfolder named All. Next, copy the code from the Better Auth docs. Paste it into the root.ts file. After that, add any imports that are missing for the modules used. The next step is to create a client instance for the front end. Create a new file inside the lib folder we created earlier. Copy the code from the documentation and paste it into this file. Update the base URL to match the value in your environment variable file. The Better Auth installation is now complete. The setup is fully finished and ready to use. Next, we will create the authentication pages, a sign-in page, and a sign-up page, along with any additional pages needed for the full user flow. We will use a package called Better Auth UI, which handles all authentication pages automatically. To find this package, open a web browser and search for Better Auth UI. Click the official link to visit the website. Better Auth UI is built using the shadcn library. It automatically generates all required authentication pages. Before using it, we need to install two packages, shadcn UI and Sonar. Visit the shadcn website and navigate to the Getting Started section. On the Next.js installation page, copy the command provided by the setup utility. Return to Visual Studio Code, paste the command, and run it. When prompted, press Y to confirm the installation. Next, select the base color option for shadcn. For this project, choose the Nova color scheme. The shadcn component library has been installed successfully. Let's return to the requirements section for the next step. The next requirement is to install Sonar. Copy the installation command for Sonar. Then go back to Visual Studio Code and paste the command to run it. Now that Sonar is installed, we need to add it to our main layout file. Copy the provided code snippet so we can include it in the layout. Return to Visual Studio Code and open the main layout file. Paste the code snippet directly after the children section, and then add the required import from the component's UI directory. The installation process for Sonar is now complete. We can move on to the next configuration step. Go back to the Better Auth UI website. We already have Tailwind CSS version 4 installed. The next step involves the global CSS file. Copy the code snippet provided in the documentation. Return to Visual Studio Code and open the styles directory. Paste the code at the very top of the global CSS file. This ensures the styles are applied correctly across the app. Once that is done, proceed to the next instruction. The next step is to create a providers file. In Visual Studio Code, navigate to the Components folder. Inside that folder, create a new file named providers.tsx. Copy the entire code block from the documentation and paste it directly into the new providers file. First, fix the import issues in this file. After that, install the required package. This package will provide the Authentication UI provider. Next, we need to add this provider to a layout file. Instead of using the main layout, we target only authentication pages. Create a new folder named Auth with parentheses. The parentheses are important as Next.js automatically ignores this folder in the URL. Inside the Auth folder, create another folder named Auth. Inside this second Auth folder, create a folder named Path in brackets. Check that the path folder name is wrapped in brackets. Inside this bracketed path folder, create a new file named page.tsx. Open the Better Auth UI website in your browser window. Carefully look for the code example that shows the page component. Highlight the entire code block with your mouse cursor. Copy the selected code from the Better Auth UI example. Paste this copied code into your new page.tsx file. Save the page.tsx file to confirm everything is in place. Looking at the final version of our app, we see the sign-in page layout. On the left, there is a visually appealing section. On the right, the main sign-in or sign-up component is displayed. This layout code is placed inside the layout.tsx file. The layout itself is static. It doesn't have interactive functionality. Its purpose is to provide the visual structure for the authentication forms. To save time, I will copy the layout code directly from our GitHub repository. The complete code is available there. Create a new layout.tsx file in the main auth folder. Paste the layout code into this file. Next, wrap everything with the provider component we created. The provider wraps the authentication pages and provides context for state and functionality. On the layout, the left side is purely visual. It includes elements like the logo and other design features. The right side displays the authentication form. This form dynamically loads all required components from our authentication folder. Next, add a new attribute named redirected to. Place it inside the page.tsx file we created earlier. This will automatically send users to the dashboard after they sign in. Next, we need to turn on our server. Clear the terminal and run npm run dev. Then open our website in the browser. We can now see the sign-up page loading correctly. The interface looks exactly as intended. Next, test the sign-up process by creating a new user account. For the email, we can use something simple like sahand@gmail.com and enter the same password. We have been successfully redirected to the dashboard page. Check the users table in our Neon database. We can confirm that the new user was added successfully. Now navigate back to the sign-in page and test the login functionality using the same credentials. The login process works perfectly. The authentication functions exactly as expected. After logging in, check that the session cookie exists. Open your browser developer tools, go to the application tab, look under cookies for your local site. You should see a BetterAuth session cookie listed there. This confirms that our authentication setup is complete and fully functional. We have successfully implemented secure user sign-up and login processes. Let's commit our authentication setup to the GitHub repository. Stage all the changes, use a clear commit message, and then commit and push the updates. See you in the next section. Welcome to this section where we will focus on the dashboard page. Our main task is building the sidebar component for the interface. Take a look at the finished application. You will notice a sidebar positioned on the left side. The sidebar contains the main navigation menu for the application. At the very top, you will find our application logo. Next, the user's current credit balance is displayed. A button is available for upgrading the account. The account information section is located here. It includes a menu with several options. You can access the customer portal from this menu. You can also navigate to your settings. Finally, you can sign out of the application. The sidebar component is designed to be fully responsive. It automatically adjusts to work perfectly on all devices. Shrinking the screen down to mobile size, you can see a mobile menu appear. This menu can be opened and closed using the button at the top. The sidebar adapts perfectly. The mobile sidebar opens fully when needed, allowing you to view all menu items on a smaller screen. At the top of the page, you will notice a breadcrumb navigation. This breadcrumb clearly indicates which menu item is currently selected. When I click on a menu item, the breadcrumb updates to display the word transcribe. For building our sidebar, we will use a pre-built component from ShadCN. This component is specifically named Sidebar. It provides all the essential features needed to build a polished sidebar for our application. First, we need to install the sidebar component. Then, we must create a dedicated folder specifically for the dashboard. All dashboard-related components and files will reside in the separate folder. This organizational structure keeps the dashboard completely separate from the authentication pages. The dashboard will have its own layout file. This layout will contain all the shared components for the dashboard section. Looking at the finished application, you can see the dashboard layout includes the sidebar and the breadcrumb component. All elements on the page are included, and every single page in the dashboard uses these exact same components. Let's start by creating our dashboard page. Create a new folder inside the app directory. This folder will be named Dashboard with parentheses. Inside this folder, create another folder also named Dashboard. Inside this folder, we will create the main page file called page.tsx. This file will serve as the dashboard page. We need to create a layout file for the dashboard. The file will be named layout.tsx. Let's begin by creating a simple layout. This layout will receive the children components and display them. It will primarily render the content from our page file. Let us check our website. You can now see the dashboard page is ready. It is accessible at the /dashboard route. Next, navigate back to the ShadCN documentation. We need to install the sidebar component first. Copy the npm install command from the documentation, return to Visual Studio Code, and paste this command into the terminal. Make sure you are inside the front-end folder. This command will install several useful components for our project, including a separator, a sheet, a sidebar, a skeleton, and a tooltip. We have a few more important tasks to complete in our layout file. Let's address these items at the very top of the layout component. But first, let's remove this HTML and body tag to fix the error. Now let's first import the global CSS file into the layout. This ensures all necessary styling rules are applied correctly. Next, import the providers component. This is an important step for the application to work as expected. Earlier in the project, we built a special component called providers. It handles all the authentication logic and wraps the entire application. This ensures the authentication system works consistently across the app. The dashboard now has full access to all authentication features. We also need to import the toaster component from the Sonner library. This allows us to display toast notifications inside the dashboard. Next, integrate this toast component into the application to ensure notifications appear correctly. Now, import several items from the sidebar component, including sidebar inset, sidebar provider, and sidebar trigger. Update the code carefully to match the example provided in the documentation. Finally, wrap the entire layout with the sidebar provider. This ensures the sidebar works correctly across all components. Now, if we look at the final application, you'll notice a dividing line. Let me zoom in on this section to make it easier to see. This vertical line is called the separator component. We already have the separator installed in the project, so it is ready to use. Next, we need to import the separator component. The breadcrumb component displays the current page in the dashboard header. It shows which section you're actively working on. In the final version, you can see that we are on the settings page. The breadcrumb correctly displays the word settings. If we navigate to the history page, it will show history instead. Now, let's install this component using the Visual Studio Code terminal. Next, let's add some metadata to the layout file. This metadata defines the page title and description. We'll set the title to AI speech to text. The description and icon are also defined in this section. We place all page content inside a main section. The remaining elements are positioned inside a header area above the main content. This header contains 3 important elements. First, we have the sidebar trigger button. Next, we add a visual separator line. Finally, we include the dynamic breadcrumb component. For example, if you type settings, it should immediately appear on the website. You can see the word settings displayed clearly. We cannot hard code the word settings here. Instead, we need to fetch the current URL and display the correct page name based on it. Go back to Visual Studio Code and continue building the breadcrumb component. First, create a new folder called Sidebar inside the Components directory. Inside that folder, create another file called breadcrumb page client tsx. Next, we'll build a React functional component for the breadcrumb. This component will handle displaying the navigation title. After that, we add the new breadcrumb component to the dashboard layout. This component needs to run on the client side because it requires user interaction. Add the use client directive at the top of the file. Then import the use path name hook from Next Navigation. We'll use the use path name hook to get the current URL path. Based on that path, we can dynamically display the correct breadcrumb. For example, when the URL path is exactly dashboard, we want the breadcrumb to display dashboard. We need to handle different URL paths inside the breadcrumb. For the dashboard create path, we want it to display transcribe. The breadcrumb component will always show the correct title based on the page path. Now let's open the website to see the result. The dashboard breadcrumb is now visible because we are currently on the dashboard page. Our breadcrumb component is working exactly as expected. Next, we will finish building the sidebar component. We will create a separate component called App Sidebar and integrate it into the dashboard layout. Open Visual Studio Code and navigate to the sidebar folder we created earlier. Create a new file named appsidebar.tsx. This file will contain our React functional component, also named App Sidebar. Next, add the App Sidebar component to the dashboard layout file. Place it at the very top of the layout right after the opening tag of the sidebar provider. Make sure to import the component into the layout file as well. This component is designed as a server-side component, meaning it will render on the server first. To achieve this, we use the useServer directive. The main page content will render afterwards. Server actions must be async functions. First, import the user button component from BetterAuth. This component displays a menu with the user's information. You can find it in the BetterAuth UI documentation. Next, import the sidebar components to build the layout. We also need a few icons for the sidebar items. Import the link component from Next.js to navigate between pages. Start by wrapping the application components with sidebar, sidebar content, and sidebar group elements. The structure ensures the layout works correctly. Next, we have the logo at the top of the sidebar. This is the first element users will see. Add a sidebar group label component, and inside it, place a link element that redirects to the home page. Include a sparkles icon and display the speech to text. Clicking this logo will redirect users to the home page. Now review the changes in the web application. Next, we'll add a sidebar footer section. This footer will contain the user button from BetterAuth placed at the bottom of the app sidebar component. The user button includes several configurable properties. We can customize its behavior and appearance using these attributes. One important feature is the additional menu links. These links provide extra navigation options for the user. We want to include a link that takes the user to the customer portal at the dashboard customer portal URL. We also need another link that navigates to the settings page. If you look at the website now, you can see the footer section. Now we need to build the main navigation menu. Our menu includes 4 items: dashboard, transcribe, history, and settings. Navigate to the sidebar folder. We will create a new file for our menu component here. Next, we will create a React functional component to serve as the menu navigation. Let's name this function sidebar menu items. This will be a client-side component. Import the necessary icons from the Lucide React library. Import the usePathName hook from Next.js navigation to highlight the currently selected menu item. Also import several elements from the shadcn sidebar component. Import the link component from Next.js to allow navigation between pages. Import cn from our utility functions to combine Tailwind CSS class names. Use the usePathName hook to get the current page path. Create a hook to handle mobile devices using the useSidebar hook from shadcn. This helps us check the current screen size and determine if we are on a mobile device. Next, define an array of menu items representing the navigation options in the sidebar. The items are dashboard, transcribe, history, and settings. Each item has a destination URL and a unique icon. We then determine which menu item should be active based on the current page URL path. Loop through all menu items and check if the URL matches the current path. If it matches, mark that menu item as active. Finally, focus on the return statement to ensure all menu items render correctly in the sidebar. At this point, we'll return all the menu items we defined earlier. This will display each item inside the sidebar navigation. We'll start by using the sidebar menu item component. Next, we'll iterate through each menu item in the list and render it using the sidebar menu button component. Each menu item is represented as a button. The component itself is a button element, so we avoid nesting buttons to prevent errors. A menu item is only active when its active property is set to true. The appearance changes based on the active state. Each menu item navigates to its correct page when clicked. On mobile devices, the menu will close automatically whenever a user taps on any menu item. To handle this, we will create a function called handleMenuClick. This function ensures that the mobile sidebar closes automatically after a menu item is selected, improving the user experience. We will also display the title for each menu item as the label on the button. Open the browser to see the menu items in the application. The dashboard menu item should be highlighted as active. Currently, the menu items may not appear yet, so we need to integrate the new menu component into the main sidebar layout. Add it right after the label section inside a sidebar group content container. Check the website now. The menu is fully visible on the dashboard page, with the dashboard item highlighted as active. Next, let's ensure the sidebar works correctly on mobile devices. Use the browser's developer tools to switch to a mobile screen size. Refresh the page if needed. The sidebar works, but mobile users currently have no dedicated button to close the menu. We need a new component specifically for mobile users. This component will display a close icon button, allowing users to easily close the sidebar. Navigate back to Visual Studio Code and create a new React functional component. This component must be client-side to handle user interactions. Import the X icon from Lucide React, the Use Sidebar hook from ShadCN, and the button component from ShadCN. Use the Use Sidebar hook to get set open mobile and determine if the sidebar is in mobile view. If the device is not mobile, return nothing. Otherwise, return a button containing the X icon. Clicking this button closes the mobile sidebar. Next, add this mobile sidebar close component to the app sidebar. Place it immediately after the opening sidebar content tag. Refresh the website and click the menu icon to open the sidebar. You will see the navigation menu appear along with a small cross icon in the corner. Users can close the menu either by clicking the cross icon or by clicking outside the menu area. Let me also check the error and fix it. At this point, the sidebar menu component is complete and we don't have any errors showing. In the next section, we will add the user's credit balance displayed clearly inside the sidebar. Before moving on, commit your progress to GitHub with the message, add sidebar components and utilities. In the next tutorial section, we will add the user credits display, so see you in the next section. In our previous section, we successfully built the sidebar user interface. In this section, we will retrieve the user's credit information and display it in the sidebar footer. The first step is to create functions to retrieve the user's credit information. We'll start by creating a new file named credits.tsx. Open Visual Studio Code, navigate to the src folder, and create a new folder named Actions. Inside this folder, create the credits.tsx file. Add the useServer directive at the top of the file. This ensures the functions operate exclusively on the server side, so website visitors cannot directly access them. This is a crucial security measure to protect user data. We'll create a function called getUserCredits. This function should use caching to store the user's credit value, temporarily preventing repeated database requests. The function will be asynchronous and include error handling with a try-catch statement. Inside the try block, first retrieve the user session using the getSession method from Auth. If the session is not found, return success, false with an unauthorized error message, and set credits to 0. If the user is authenticated, query the database using findUnique on the user table with the user's ID from the session. Select only the credits field. If no user is found, return success, false with a user not found error message, and credits set to 0. If the user exists, return success true and include the user's credit value. In the catch block, log any errors to the console and return success false with a default credits value of 0. The getUserCredits function is now fully implemented. It securely retrieves the user's credit balance from the server. We can now use this function to display the user's credits directly in the sidebar component. Next, we will create a new component inside the sidebar folder to display the user credits. We will import the coins and sparkles icons from Lucide React. We also need to fetch the user credits using our new function. We will retrieve the user's credit information by calling the function with the await keyword. We must make our function asynchronous. We create a new constant called credits. Next, we check if the result was successful. If it was, we retrieve the credits value from the result. Otherwise, we default the credits value to 0. The component will now return a simple piece of code. It includes icons for coins and sparkles. It also displays the user's credit value. Finally, it shows the word credits next to the number. Our credits component is now ready for use. We should place it inside the sidebar component. Let's open the app's sidebar component file. We will place our credits component inside this div element right after the opening tag for the sidebar footer. We can now check our application to see the credits displayed. Navigate back to the main application interface and refresh the page to see the changes. The current balance shows 10 credits. New users receive 10 credits when signing up, allowing them to try the service immediately. Next, navigate to the Neon database interface. Manually change the user's credit value, for example, to 50. Refresh the page to see the updated balance. The footer should now display 50 credits. We have successfully added the user credits display to the sidebar footer. This feature is fully integrated and working. Commit these changes to your local repository and push the update to GitHub. The next section focuses on building the upgrade button. This button will allow users to purchase more credits. We will also integrate the Polar service to enable account upgrades and credit purchases. See you in the next part of the tutorial. We successfully built the credits functionality in the previous section. Everything for handling user credits is now fully implemented and working. Now we will focus on implementing the upgrade button. This button will allow users to purchase more credits. To handle payments and upgrades, we will use a service called Polar. First, open a web browser and go to the website polar.sh. Make sure you are logged into your Polar account. The service is free to use and is available in most countries. Unlike Stripe, which has limited availability, Polar can be accessed almost everywhere. The first step is to access the sandbox environment. This is a testing mode perfect for development. The sandbox functions identically to the live production environment, but is designed for testing purposes. Click the sandbox button to access it. Next, create a new organization. Choose a name for your organization. For this example, we will name it AI Speech to Text. Navigate to the product section. Here we will add 3 distinct products to the organization. These products represent different credit packages for users. Start with the first product called the Small Pack. This pack will give users 50 credits. Set it as a one-time purchase with a fixed price of $4.99. Next, create the Medium Pack. This pack provides 200 credits. Set the price for the Medium Pack to $14.99. Finally, create the Large Pack. This pack includes 400 credits for users to purchase. Set the price for the large pack at $19.99. The next step is to install the Polar SDK into our project. This allows the application to handle payments and credits. Polar integrates through BetterAuth. Navigate to the BetterAuth website. Find the third-party integration section and select Polar to add it to your authentication setup. Install the necessary packages for Polar integration. You will need two packages, Polar BetterAuth and Polar SDK. Copy the installation command and run it in your project using npm. Next, retrieve your environment variable from the Polar dashboard. Go to the Settings section in Polar. Scroll down and create a new access token. Name the token AI Speech to Text. Set the token to have no expiration date and select all available scopes for full access. Once the token is created, copy it, then add it to your project's environment variables file. You must also add this token to your environment type definition file. This step ensures your application remains type safe. Let us take a look at the BetterAuth website again. We need to add the Polar integration to our project's Auth settings. I updated this code based on a suggestion from the BetterAuth website. You can find this code in the GitHub repository linked in the resources section. This client will handle the connection to the Polar service. We need to access our Polar access token here. We created this token earlier inside our environment file. We are currently operating in sandbox mode on our server. The sandbox environment is specifically designed for safe testing. Looking at the BetterAuth documentation, we must add a specific plugin. This plugin integrates Polar directly into our authentication system. We need to define our checkout process and list the available products. We also need to set up webhooks to handle payment notifications. This plugin integrates Polar functionality into our application. It allows us to handle purchases and manage customer accounts seamlessly. We will now initialize and use the Polar client in our configuration. When a user signs up with BetterAuth, we automatically create a corresponding Polar account for them. This ensures their purchase history is properly linked. For the checkout process, we want to include all three of our products. These are the small, medium, and large credit packs. Our next step involves gathering the product IDs for each credit pack. You can find these unique identifiers directly in the Polar dashboard. Let's navigate back to the Polar dashboard. We are going to find the product section. Now we need to get the product IDs from the Polar website. Let's copy each product ID from our list. We can just click here and copy the product ID. We also need to configure webhooks. Webhooks will automatically trigger an API route in our application. This happens as soon as a purchase is successfully completed. To make webhooks function properly, we must first create a webhook secret. The secret is generated within your Polar account settings. Let's navigate back to the Polar dashboard. We need to go into the settings section. Then we will find the webhooks menu. The next step is to add a webhook endpoint. We need to provide a URL for Polar to send notifications. There is one crucial point to understand about Polar. It cannot process webhooks from a local development URL. Webhooks require a publicly accessible internet address to function properly. We must install a third-party package called ngrok. This tool creates a real public URL for our local server. This is necessary because Polar requires a live web address. Let's search for ngrok on Google to find the official download page. Since I am using a Mac, I will download the Mac OS version. I will copy this installation command. Then we can navigate to our terminal. I will now paste this command into the terminal to install it. This command will install Grok on my computer. It sets up the tunneling software we need. Once the installation finishes, we are ready to create our endpoint. We need to copy this command from the ngrok documentation. After copying, we will return to our terminal application. Our port number is localhost 3000. We need to specify this for the tunnel. Excellent. Grok has now generated a public URL for our local server. I will copy this unique URL that Grok generated. Then I will paste this URL into Polar's webhook settings. Now we need to add our webhook endpoint. The endpoint should look like this at the end. For the data format, we will select the raw option. Then we need to choose the specific event to listen for. We will use the order paid event for this. Let's go ahead and create that webhook endpoint. Now, after creating the webhook, copy the secret key. You should add the secret to your environment variables file. The environment variables are now properly configured. We can see that the previous error has been resolved. When an order is paid, we want to send a signal back to our application. This lets our system know the purchase was successful. If there is no customer ID, we will log a message to the console. The message will state that no external customer ID was found. Otherwise, we will first retrieve the product ID. Then we will grant the user their purchase credits. We will start by creating a variable named credits to add. We will set its initial value to 0. Then we check the product ID. Based on that ID, we will assign the user a specific amount of credits. This could be 50, 200, or 400 credits. Once the payment is successful, we need to update our user's information. We will add the purchase credits to their account in the database. We need to import our database connection here. Then we will find the user in the database first. After that, we can add the credits to their account. We want to add these purchase credits to the user's account balance. This will update their total available credits immediately. Let's test our setup by creating a new user account. We need to verify this user appears in the Polar customer list. This confirms our integration is working correctly. Let's return to our application. Now let's log out. We will create a brand new user account for this test. I will use a real email address for this test. I need to check my Polar account for the correct email. Let's begin by creating a new user account for testing purposes. After we create the new user account, we can navigate to the Polar dashboard. When we check the customer section, the new user appears there as well. Every user who signs up for our application is now connected. We have access to their email address and purchase history. This integration provides us with complete customer data. Our next step involves adding a purchase button to the application. This button will redirect users to the Polar payment page. We need to create a new component for this. Now we will place this component inside the Sidebar folder. Next, I will create a new component for the Upgrade button. This component will be named Upgrade TSX. This component needs to be a client-side component. The Upgrade button requires interactive functionality that only runs in the browser. We also need to remember another important step here. We must add the same plugin on the client side as well. Next, we need to go to the Auth client file. We should add the same plugin at the bottom of that file. This essential import comes directly from the Polar BetterAuth library. We will use the Auth client we set up earlier. We also need to include our product IDs here. Let's navigate back to the Polar dashboard. We need to copy the product IDs for our packages. We will return a simple button element from this component. We need to import the Shadcn button component. We will create a button labeled Upgrade. This button will call a specific function when it is clicked. This button initiates the checkout process for the selected product. We also need to import icons from Lucide React. We will use a crown icon and a sparkles icon for the button. We can now add this component to our sidebar. Let us place it right after the credits button. We will use the test credit card payment option. This option is specifically designed for testing purposes. You can see the name field is already filled in here. Seems like there is a problem with adding the credits. Let's go back to the polar. Here where the purchase is done for the user, but the credits is not added. I think we need to check the webhook section to find the problem. Let's check the details. I think this one must be API/auth/polar webhooks. Let's save it. The secret should be the same. Let's try the application one more time. After you complete the payment, you can see that your credits have been updated. You started with 10 credits and now you have 60 credits. You will receive an email from Polar with the AI speech-to-text title. This email contains your order confirmation. You now have 50 additional credits available. You can click right here to view and download your invoice. The website owner also receives a confirmation email for the purchase. This email confirms the purchase of a small pack. The best part is that Polar manages many website tasks. It even sends confirmation emails for you. Our next step is to create the customer portal. At the moment, the customer portal feature has not been implemented yet. To create the customer portal, we need to add a new folder. This folder will be called Customer Portal. You should place this folder inside the dashboard directory. We are going to create a page TSX file. This file will give us the Customer Portal page. The route will be Dashboard Customer Portal. Let's begin by creating the folder for our Customer Portal. We will place this new folder inside the dashboard directory. Let's go back to our Visual Studio Code editor. We need to navigate to the dashboard folder. Next, I will create a new folder named Customer Portal. Inside this folder, we will add a file called page TSX. This component is designed to be asynchronous. It will run on the server side. We need to retrieve the user's current session information. This data comes from our BetterAuth authentication system. We also need to import the headers function from nextHeaders. Now we need to set up a basic condition here. We will check whether the user has an active session. If no session is found, we will redirect the user to the sign-in page. We need to import the redirect function from Next Navigation. This function helps us manage page redirects in our application. At this point, we will return a component called Customer Portal Redirect. Our next step is to create this component. Let's navigate to the Components folder. We are going inside the Sidebar directory. Next, I will create a new file for the Customer Portal Redirect. This customer portal page has an important responsibility. It checks whether the user is properly logged in. Once the user is authenticated, we will redirect them to their customer portal. Now we need to ensure authenticated users are redirected correctly. For this reason, we must make this a client-side component. This is required because we are using a React hook. We will add a useEffect React hook to this component. We will use a method called portal from our client configuration. This method redirects the user to the Polar customer portal interface. This component first checks the user's authentication status. After that, it redirects them to the Polar customer portal. While this process is running, we display a simple loading state. We are using the loader component from the Lucide React library. Let's test the customer portal inside our application. Here we can see the order details displayed correctly. It confirms that our small package purchase was successful. You can navigate to the billing section from here. In this section, you can change your current payment method. You also have the option to add a new payment method. You can update your billing address directly on this page. You can view your full order history and download invoices. All invoices are available as PDF files for easy access. All of your account management tools are available in this single portal. The integration is now fully operational. All payment and customer portal features are working exactly as expected. We have successfully integrated Polar into our application. This integration delivers a complete payment solution for our users. It handles secure transactions and full customer management. Now let's commit our changes to GitHub to save our progress. This covers everything needed to integrate Polar into our application. We will see you in the next section to continue with the next steps. In the previous section, we finished building the upgrade feature. In this section, we are going to build the settings page. This page allows users to manage their personal account details. Our next task is to create the settings page for our application. Creating the settings page is actually very simple. All we need to do is create a folder named settings. Then inside that folder, create a file called page.tsx. Let us begin by creating that folder and file. Let's navigate back to the File Explorer. We will navigate to the Dashboard section of our project. Next, let's create a new folder named Settings. Inside that folder, we will create a page.tsx file. We will use a pre-built component called the Account Settings card. This component provides all the essential user interface elements. It includes an avatar, display name, and email fields. There is also an option for users to change their password. We will mark this component to run on the client side. We need to import 4 specific components from Better Auth UI. These components are redirect to sign in and security settings card. We also need the signed in component. Finally, we must import the account settings card. We also need to import a component called loader from Lucide React. This will show a loading animation while the page is getting ready. We need to use the Auth client we set up earlier. This client will help us get the user session information. We also need to import 2 important hooks from React. We need useEffect and useState. We are going to start by adding a state variable called isLoading. We set this initial value to true. We use the React useEffect hook. This hook will check the user session status. We will check the user session to make sure everything works correctly. We need to ensure that the session is valid. We check if there is no active user session. We should throw an appropriate error in that case. After confirming everything works as expected, we can set isLoading to false. Once the useEffect hook runs, we add a conditional check. While the page is still loading, we display a loading indicator. This gives the user clear feedback. Otherwise, we return the actual settings page content. The settings page itself is simple to set up. First, we check if the user is logged in. If not, we automatically redirect them to the sign-in page. If the user is signed in, we will display the full settings interface. We will start by adding a header for the account settings section. This header will explain that you can manage your personal preferences. Next, we will use the account settings card from Auth UI. We will also include the security settings card component. These components show all the relevant account management features. Let us take a look at our application to see the updates in action. You can now see the header displayed clearly at the top of the page. You also have the option to change your display name. You can update your email address directly from this page as well. There is an option to update your password easily. You can also view all of your active user sessions here. You will also find a logout button conveniently on the page. This allows you to securely sign out of your account at any time. The settings page is now fully functional with all necessary features. That was a very straightforward process to complete. We simply use this account settings component from Auth UI. It automatically adds all the required features to our application. Let's save our progress now by committing the new settings page. In the upcoming section, our focus will shift to back-end development. In this section, we will install our speech-to-text model. We will then add it to a service called Modal. Once deployed, we can run our audio transcription pipeline. We will then use the generated transcript in our front-end application. Now let me show you exactly which model we will be using. Search for the Cohere Transcribe model. This is the specific open source model we will use for our project. For more details about this model, you can visit its page. This model is completely free to use and is licensed under Apache 2.0. It delivers strong multilingual transcription quality while maintaining excellent speed. You can see example outputs on this page and test the model yourself. For our tutorial, we will use the Hugging Face page. On this page, you will find the complete installation instructions. We need to install the model using this specific command line utility. We will not install the model on our local computer. Instead, we will install it on a remote GPU service called Modal. Let's search for the Modal platform on Google. You can navigate to modal.com in your web browser. Modal is a high-performance AI infrastructure platform. It provides dedicated GPU resources for running AI models efficiently. This infrastructure gives your model access to powerful GPUs. The service only runs when you make a request. When it is idle, it stays offline and costs nothing. When you call the service, Modal loads the model onto a GPU automatically. This platform uses a serverless execution model. It can handle many different types of AI services. When you first log into Modal, you receive a monthly credit of $30. This free credit is provided to you every single month automatically. Modal gives you $30 in free credits on a monthly basis. With this credit, you get access to 10 powerful GPU machines. You can also run up to 100 separate containers at the same time. I will explain what these resources actually mean later in the tutorial. This monthly credit is more than enough for testing your application. It is actually very generous for development and experimentation. The current billing period is already 16 days in. My current usage is only about $8.50. In most cases, you will never need to pay anything for this service. This is especially true while testing and building your own application. The free monthly credits are more than sufficient for our needs. Now let's navigate back to our Visual Studio Code editor. We are going to open the backend folder. Next, we will create a brand new directory. This directory will be named Speech to Text. Inside that new Speech to Text folder, we will create a requirements file. This file tells the system which Python packages need to be installed. It lists all the dependencies required for our project to run correctly. This makes sure the environment is set up exactly the way we expect. We start with Modal. Modal is a cloud execution platform that lets you run Python code remotely. It is especially useful for AI workloads because it handles scaling, GPUs, and infrastructure automatically. Next, we have Pydantic version 2.7 or higher. Pydantic is used for data validation and parsing. It ensures that any data coming into your application is structured correctly and prevents runtime errors caused by invalid input. Then we have Fast API with the standard extras. Fast API is a modern web framework used to build APIs quickly and efficiently. The standard extras install additional useful tools like automatic documentation, validation, and better performance features. Next is Requests. Requests is a simple and popular library used to make HTTP calls. It allows your application to communicate with external APIs or services. After that, we have Torch, also known as PyTorch. This is one of the most widely used deep learning frameworks. It is used for building and running neural networks, especially in AI and machine learning tasks. Next is Accelerate. Accelerate is a library from Hugging Face that helps run models faster across different hardware setups. It simplifies working with CPUs, GPUs, and even distributed systems. Then we have Hugging Face Hub. This library allows you to download, upload, and manage models from the Hugging Face ecosystem. It acts as a central place to access pre-trained AI models. Next is Soundfile. Soundfile is used for reading and writing audio files. It is commonly used when working with audio data in machine learning pipelines. After that, we have Librosa. Librosa is a powerful library for audio analysis. It is used to process sound, extract features, and prepare audio data for machine learning models. Next is SentencePiece. SentencePiece is a tokenization library used in natural language processing. It converts text into smaller units that models can understand. Then we have Pro2Buff, short for protocol buffers. This is a data serialization format developed by Google. It is used for efficient communication and storage of structured data. Finally, we install Transformers directly from GitHub. Transformers is a library by Hugging Face used for state-of-the-art models like GPT and diffusion models. Installing it from GitHub ensures you are using the latest version with the newest features. That's the full requirements file. Together, these libraries allow your project to run APIs, handle data, process audio, and power advanced AI models efficiently. In the next step, we create our main backend file ztranscribe.py. This file defines our serverless API endpoint. This endpoint handles speech-to-text requests for our application. We start by importing base64. This is used to decode audio that comes in as a base64 encoded string. Next, we import I/O. This allows us to treat raw bytes like a file in memory. Then we import OS. This is used to access environment variables like API keys and configuration values. Next, we import Modal. This is the platform that runs our code in the cloud with GPU support. After that, we import base model from Pydantic. This is used to define and validate the structure of incoming requests. Now we create a modal app and name it zSpeech2Text. This is the main container for everything in the service. Next, we define the model ID as Cohere Transcribe 03-2026. This is the speech-to-text model we will load from Hugging Face. Then we define a secret called HFSecret. This retrieves a Hugging Face token securely from modal secrets. Next, we create a list called secrets and include that token. This makes the secret available inside our app. After that, we define a volume called VOL. This is used to cache downloaded models, so they don't need to be re-downloaded every time. We mount this volume at a path called models. Now we define a custom image. This is the environment our code will run in. We start from a slim Debian image with Python 3.12, then we install system packages like ffmpeg and git. After that, install all Python dependencies from the requirements file. Finally, we set environment variables so Hugging Face stores models inside the models directory. Next, we define a request class called REQ. This uses Pydantic to validate incoming data. It includes audio-base64, which is the encoded audio input. It also includes language, which defaults to English. Now we define a class called zTranscribeServer. This is the main service that will handle transcription. We decorate it with modal settings. We attach the custom image. We request a GPU defaulting to L40S. We set a timeout of 900 seconds. We configure a scale-down window of 600 seconds to save resources. We mount the model's volume, and we attach our secrets. Next, we define a special method called load. This runs once when the container starts. Inside this method, we import Torch and the required Hugging Face classes. Then we retrieve the Hugging Face token from environment variables. We clean it by removing extra spaces or quotes. Next, we load the processor using autoprocessor. This handles audio pre-processing and decoding. Then we load the model using Cohere ASR for conditional generation. We pass the model ID and token. We set the data type to float16 for better GPU performance. Then we move the model to the GPU. Now we define an API endpoint called Transcribe Audio. This endpoint accepts post requests. Inside the function, we import Librosa for audio processing. First, we decode the base64 audio into raw bytes. Then we load the audio using Librosa. We convert it to a sample rate of 16,000 and ensure it is mono. Next, we pass the audio into the processor. We include the sampling rate and language. We also request the output in PyTorch tensor format. We extract something called audio chunk index if it exists. This is used for handling long audio inputs. Then we move all inputs to the same device and data type as the model. Next, we generate predictions using the model. We limit the output to 512 tokens. Now we handle decoding. If the audio chunk index exists, we use a special decode method that supports chunked audio. Otherwise, we use batch decode to convert the output into text. We take the first result if multiple outputs exist. Finally, we return a response. This includes the transcribed text, the model ID, and the detected or selected language. Before we proceed, we should set up a Python environment in our backend directory. This environment will help manage all project dependencies cleanly. Before moving forward, make sure you have the necessary extensions installed. You will need the Python extension for Visual Studio Code. This includes the Python environment and debugger. You should also install the Pylons extension first. Make sure all these extensions are installed before continuing. Next, open your terminal and stop the current server process if it is running. Now, navigate back to your project directory. Go into the backend folder to continue setup. Next, you need to run the Python 3 command to create your environment. After that, you will run the source command to activate it. You can see we are now inside our virtual environment. You should see these parentheses appear in your terminal. This confirms your virtual environment is active. You will also notice a new folder has been created. Next, we need to install the Modal SDK into our backend application. This step allows our code to communicate with the Modal platform. Let's head back to our browser and open a new tab. We will open a fresh browser tab together for this step. In the address or search bar, type Modal documentation, look through the results, and select the official Modal website. On the Modal homepage, find the Guides section, open the Getting Started guide that explains installation steps clearly. Before you continue, confirm your virtual environment is still active. Check your terminal prompt for parentheses to verify this state. In the Getting Started guide, find the Python package installation command, carefully highlight the full command without missing any characters. Copy the command using your keyboard shortcut or mouse menu, move back to your terminal that shows the active environment, paste the copied command directly into your terminal input area, press the Enter key to run the installation command. The Modal installation process has finished successfully. We are now ready to proceed with the next configuration step. Our next step is to configure the Modal setup. Next, we need to run the Modal setup command. Your API token has been successfully generated at this point. The authorization process is now complete. The next step is to deploy this file to the Modal service. First, navigate into the speech-to-text folder. Next, run the Modal deploy command to deploy our speech-to-text application. This step will make our API available online and accessible for client requests. Our deployment process has completed successfully. The application is now fully operational on the Modal service. Our application is now deployed and we have a live URL. This URL is ready to be used. Let's check the link. The application is now successfully deployed. We have created a specific function to handle this task. This function is called zTranscribe. This function is configured to run on an L40's GPU. This specific hardware provides the necessary power for our speech-to-text processing. Next, we must add this URL to our environment file. This is the address we will use for our API requests. That completes our work on the speech-to-text server. We have successfully set up the backend functionality. We now have our unique URL available. We have saved this URL securely in our environment variable file. We are ready to create the front-end page. We will use this URL to send requests to our backend. You can see this process was quite straightforward. To avoid making typing errors, you can visit the GitHub repository. You can copy the code directly from there. Let's commit our code to the GitHub repository. That concludes the process of creating our backend server. Our backend is now fully set up and working. We can shift our focus entirely to the front end. Welcome back to our tutorial on building the speech-to-text application. In this section, we are going to build the transcribe page together. We will write the core actions first. The main action is transcription, which converts uploaded audio into text. We will also create an action to fetch the user's transcription projects. Inside the actions folder, we create a file called speech-to-text.tsx. This file runs only on the server. It can safely use the database. It can also use authentication and environment variables. None of this is exposed to the client. We start by importing a function called headers from Next.js, which allows us to access request headers. These headers are later used when checking the user's authentication session. Next, we import environment variables from a local configuration file. This is where important values like the speech-to-text API URL are stored. Then we import the authentication system. This is used to verify whether a user is logged in and to retrieve their session information. After that, we import the database client. This allows us to interact with the database, including reading user data, storing transcripts, and updating credits. Now we define a structure called transcript item. This describes what a transcript looks like. It includes an ID, file name, language, the transcribed text, the model used, and a timestamp. Next, we define the structure for incoming transcription requests. This includes the base 64 encoded audio, the file name, and the language. Then we define the structure of the response returned after transcription. It includes whether the request was successful, the transcribed text, model information, and any possible errors. We also define a structure for fetching transcripts, which includes a success flag, a list of transcripts, and an optional error message. Now we move to the main function that handles transcription. This function receives audio data and returns the transcription result. We start by creating a variable to store the user ID. This is useful for debugging if something goes wrong. The first check ensures that the speech-to-text API URL exists. If it is missing, the function immediately returns an error. Next, we retrieve the user session using the authentication system. If the user is not logged in, the request is rejected. If the user is authenticated, we store their ID for later use. We then define how many credits are required for a transcription. In this case, it costs 1 credit. The system fetches the user from the database and checks if they exist. If not, it returns an error. Then it checks whether the user has enough credits. If the user does not have enough credits, the request is rejected with an error message. Next, we validate the input data to ensure that the audio, file name, and language are all provided. If any of these are missing, the request fails. Now the system sends a request to the speech-to-text API. It sends the audio in base 64 format along with the file name and language. If the API response is not successful, the system reads the error message and returns it. If the response is successful, it parses the returned data. If the API itself returns an error, that error is passed back to the user. Next, the system ensures that the transcription is in a clean string format. If the result is an array, it joins it into a single string. If no text is returned, the function stops and returns an error. Now we prepare to save the transcript. A variable is created to hold the saved result. The system then performs a database transaction. This means two operations happen together safely. First, it deducts 1 credit from the user. Second, it saves the transcript into the database. If both operations succeed, the transcript is formatted into a clean object. If saving fails, the error is logged, but the transcription result is still returned to the user. Finally, the function returns a success response, including the text, model ID, language, and saved transcript if available. If something unexpected goes wrong at any point, the system catches the error and returns a generic server error message. Next, we have a function for retrieving user transcripts. This function first checks if the user is authenticated. If not, it returns an unauthorized error. If the user is authenticated, it fetches the latest 20 transcripts from the database, ordered from newest to oldest. The transcripts are then formatted and returned as a successful response. If any error occurs during this process, it is caught and a failure response is returned. Finally, we have a function to delete a transcript. This function also starts by checking if the user is authenticated. It then looks for the transcript in the database. If the transcript does not exist or does not belong to the user, the request is rejected. If the transcript is valid, it is deleted from the database. A success response is returned if the deletion is completed. If any error occurs, it is logged and an error response is returned. After completing this action, we need to add 3 components for our create page. Let's start with the first one, the audio settings. We just need to create a folder called create inside components folder, and then you want to create a file called audio settings tsx. This component runs on the client side, which means it handles user interaction directly in the browser. We start by importing icons from a library. These include an audiophile icon, a loading spinner, and a settings icon. These are used to improve the user interface visually. Next, we import a card and card content component. These are used to create a styled container for the settings panel. As you can see, these components are not installed yet. So we need to install this card component first. So let's go to the shadcn website. And we search for card. Then we can just copy this command and paste it inside the front-end folder. Then we import a button component, which will be used for triggering the transcription action. Now we define the structure of the props that this component expects. It takes the chosen language and a function to change it. It also gets a flag that tells us if a file exists. It receives another flag that shows if transcription is running. It also takes a function for when the user clicks transcribe. After that, we define a constant list of supported languages. Each language has a label which is shown to the user and a value which is used internally. This list includes languages like English, French, German, Spanish, Mandarin Chinese, Japanese, Korean, Arabic, and more. Now we define the main component function. It receives all the props and returns the user interface. The outer container is a card with a shadow, giving it a clean and elevated appearance. Inside the card, we have a content section with some padding. At the top, there is a small header section. It displays the title settings and a short description that says configure transcription options. Below that, we have the main content area arranged vertically. The first part is the language selector. There is a label with a settings icon and the word language. Under the label, there is a drop-down menu. The drop-down shows the current selected language. When the user selects a different language, the set language function is called to update the state. The options inside the dropdown are generated dynamically by looping through the list of languages. Each option displays the language name and uses its corresponding value. Next, we have the main action button. This button is responsible for starting the transcription process. When clicked, it calls the onTranscribe function. The button is disabled if transcription is already in progress or if no file has been uploaded. This prevents invalid actions and improves user experience. The button also has a gradient background for a modern look. Inside the button, the content changes depending on the state. If transcription is in progress, a spinning loader icon is shown along with the text transcribing. If transcription is not in progress, an audio icon is shown along with the text transcribe audio. This dynamic behavior provides clear feedback to the user about what is happening. Overall, this component allows the user to choose a language and start the transcription process in a simple and intuitive way. The next component we need to create is the audio input. Let's create a file named audio input tsx. This component runs on the client side, meaning it handles user interaction directly in the browser. We start by importing several icons. These include a copy icon, an audio file icon, an upload icon, and a close icon. These are used to visually enhance the interface. Next, we import the card and card content components. These are used to create a clean container for the audio input section. Then we import a button component, which will be used for actions like removing a file or copying text. After that, we import the type definition for a transcript item. This ensures that any transcript data passed into this component follows a consistent structure. Here, we define the props that this component needs. It receives the currently selected file. It also gets a function to update that file. It receives the latest transcript as well, if one is available. Next, we define the main component function, which returns the user interface. The outer container is a card with a shadow to give it a modern, elevated look. Inside the card, there is a content section with padding. At the top, there is a small header section. It displays the title audio input and a short description that tells the user to upload an audio file to transcribe. Below that, we have the main content area arranged vertically. The first element is a file upload area. This is implemented as a label styled like a clickable box with a dashed border. It includes an upload icon and a text label. If no file is selected, it shows upload audio file. If a file is already selected, it shows change audio file. Inside this label, there is a hidden file input element. It accepts multiple audio formats such as MP3, WAV, FLAC, and others. When the user selects a file, the onFileSelect function is called with the chosen file. Next, we conditionally display information about the selected file. If a file exists, a small panel appears showing file details. This panel includes an audio icon, the file name, and the file size in megabytes. The file name is truncated if it is too long. There is also a small button with a close icon. When clicked, this button clears the selected file by calling on file select with null. After that, we conditionally display the latest transcript. If a transcript exists, a styled container appears with a soft gradient background. At the top of this section, there is a header that says latest transcript. On the right side, there is a copy button. When clicked, it copies the transcript text to the clipboard. Below that, the file name of the transcript is displayed. Then the transcribed text is shown inside a scrollable area. This allows long transcripts to be viewed without breaking the layout. This component lets users upload audio files and view details. They can remove a file whenever they need. They can also see the latest transcript. They can copy it quickly with a single click. The last component we need to create is for audio history. So let's create a file named transcript history tsx. This component runs on the client side, which means it is responsible for handling user interaction directly in the browser. We start by importing two icons. The copy icon is used for copying transcript text to the clipboard. The audio file icon is used to visually represent each transcription item. Next, we import the button component, which is used for actions like copy and delete. Then we import the transcript item type. This ensures every transcript object passed into this component follows the correct structure. Now we define the props for this component. The first prop is transcripts, which is an array containing all transcript history items. The second prop is on delete, which is optional. This function is used when the user wants to delete a transcript. The third prop is deleting ID, which stores the ID of the transcript currently being deleted. This helps show loading feedback for the delete button. Now we define the main component function. It receives all props and returns the user interface. The outer container is a div with a top border, white background, and padding. The section visually separates transcript history from the rest of the page. Inside that, there is another container with a maximum width. This keeps the content centered and responsive on larger screens. At the top, we have a title section. The section is centered. There are two decorative vertical gradient lines on both sides. In the middle, we display the heading Recent Transcriptions. The text uses a gradient effect to make it visually attractive. Below that, there is a small subtitle that says your latest speech to text results. Now we check whether there are any transcripts. If the transcripts array contains items, we display them in a responsive grid layout. This grid uses one column on small screens, two columns on medium screens, and three columns on larger screens. Now we loop through each transcript using map. Each transcript is displayed inside its own card. The card has rounded corners, a border, shadow, and hover animation. When the user hovers over it, it slightly lifts upward and changes border color. Inside each card, the top section shows file information. On the left, there is a circular gradient icon container with the audio icon inside it. Next to that, we show the file name. If the file name is too long, it is automatically truncated. Below the file name, we display the timestamp using local time formatting. Under the file information, we show the transcript text. This text is limited to 6 visible lines. A minimum height is also set so all cards maintain a consistent size. At the bottom of each card, we display action buttons. The first button is the copy button. When clicked, it copies the transcript text directly to the clipboard. This is useful for quickly using the transcribed content elsewhere. If the undelete function is provided, we also display a delete button. When clicked, it calls the delete function with the transcript ID. The button becomes disabled if the current transcript is being deleted. If it is being deleted, the button text changes to deleting. This gives clear feedback to the user. Now, if there are no transcripts, we show an empty state instead. The section is centered vertically and horizontally. At the top, there is a decorative pulsing circle background. On top of that, there is a dashed circular container with the audio icon. This creates a clean placeholder design. Below that, we display the message, "No transcriptions yet." Under it, we show a short instruction telling the user to upload audio and run their first transcription. This component shows your recent transcripts in a clear card layout. It lets you copy items quickly and delete them when needed. It also shows a friendly empty state when there is no data. We have all the pieces ready for the create page. Let's bring everything together and finish this page. Please create a folder called Create. Inside this folder, create a file called page.tsx This file is the main page where everything comes together to create the speech-to-text experience. At the top, we enable client-side rendering for this page. We also import everything needed for this experience. That includes Auth components, icons, and React hooks. We pull in server actions and shared UI components. We also include toast notifications for quick user feedback. There is also a helper function called file-to-base64. This function takes an uploaded audio file and converts it into a base64 string so it can be sent to the backend API. It uses a file reader to read the file and extracts only the base64 portion from the result. Inside the main create page component, several pieces of state are defined. There is this loading to track the initial loading state. There is this transcribing to track when transcription is in progress. There is selected file to store the uploaded audio file. There is language to store the selected transcription language. There is transcripts to store the user's transcription history. There is deleting transcript ID to track which transcript is being deleted. And there is latest transcript to store the most recent transcription result. When the page loads, a use effect runs to fetch the user's previous transcripts. It calls the getUserTranscripts function from the server. If successful, it stores the transcripts and sets the most recent one as the latest transcript. After that, loading is set to false so the UI can render. Next is the handleTranscribe function, which runs when the user clicks the transcribe button. First, it checks if a file has been selected. If not, it shows an error message. Then it sets the loading state for transcription to true. The selected file is converted into base64 using the helper function. That base64 data, along with the file name and language, is sent to the transcribe audio server action. If the transcription fails, an error is thrown. If it succeeds, a new transcript object is created. If the backend already returned a saved transcript, it uses that. Otherwise, it creates a temporary one using a generated ID. The latest transcript state is updated with this new result. The transcripts list is also updated, placing the new transcript at the top and keeping only the latest 20 items. A custom event is dispatched to refresh user credits. Then a success or warning message is shown depending on whether there was any issue saving the transcript. If anything goes wrong during this process, an error message is displayed. Finally, the transcribing state is set back to false. Then there is the handleDeleteTranscript function. This function is triggered when the user deletes a transcript. It sets the deleting state, calls the deleteTranscript server action, and removes the item from the local list if successful. If the deleted item was the latest transcript, it updates the latest transcript to the next available one. A success or error message is shown, and the deleting state is cleared. If the page is still loading, a simple spinner is displayed in the center of the screen. Once loading is complete, the main layout is rendered. The page is wrapped with authentication components to ensure only signed-in users can access it. At the top, there is a simple header with a title speech to text transcriber and a short description. Below that, the layout is split into two main sections. On the left side, there is the audio settings component where the user selects the language and starts the transcription. On the right side, there is the audio input component where the user uploads an audio file and sees the latest transcript preview. At the bottom of the page, the transcript history component displays the user's recent transcriptions. It allows copying text and deleting items from the history. Overall, this page handles the full flow of the application. It loads your user data and handles audio file uploads. It sends the audio for transcription and saves the results. It updates the interface and lets you manage transcription history. All right, now it's time to test our application. Let's go back to the website and we go to the Transcribe section. Let's upload an audio file as our input. I am going to pick a simple audio file. I will pick this one here, and let's just transcribe it by clicking on this button. It looks like something went wrong. It seems we just hit an error. This file is 3 megabytes in size. Next.js only allows 1 megabyte for the request body, so we need to update a next.js config file to remove this limit. Let us switch back to Visual Studio Code. Next, open the next.config.js file. Inside this config, I'm going to add this experimental body size limit, and I'm going to increase the limit to 10 megabytes. The default is 1 megabyte, so we change it to 10 megabytes. You can choose any number you prefer. Then we're going to stop the server and run it again. Because we have changed a config file, we need to restart the server. Okay, now let's go back to our website here. Let's refresh this page. And here I'm going to choose that file again and click on Transcribe Audio. Once we click on that, this is going to send a request to our backend. Let's refresh the page inside the modal. As you can see now, we got the request to this application. The first request is slower because the GPU is cold. The next request will be much faster. You can also watch the logs to see each request and response. You can open this page and confirm that the server is running. As you can see here, the first startup took about 20 seconds. At this point, the status shows successful. The execution time is 16 seconds. Let us return to the page. You can see the file is already transcribed. Let us run the transcription one more time. This time, the GPU is already warm and ready. As you can see, this run was much faster. The execution time was only 3 seconds. Let us pick a different audio file this time. Let me choose another file in Spanish, for example. As you can see, it is working well. This time it took around 2.5 seconds. This completes the steps for creating our transcribed page. Let us add this change to GitHub. We will commit all updated files. In the next section, we're going to work on the history page. So see you in the next section. In our previous section, we successfully finished building the create page. In this section, we will build the history page. This is where users can view all of their projects. Looking at our final application, you can see a problem. The projects page currently shows a 404 error. This happens because we have not built this section yet. Let us return to Visual Studio Code. Navigate into the dashboard directory, create a new folder there named Projects. We will now create a new file inside that folder. This file will be named page.tsx. This file is the main page for displaying and managing the user's transcript history. At the top, we enable client-side rendering for this page. We also import everything we need for this component. That includes authentication helpers, icons, and React hooks. We also bring in server actions and UI components. We include navigation tools to move between different dashboard pages. Inside the main project's page component, several pieces of state are defined. There is loading to track the initial loading state. There is transcripts to store all transcript items. There is filtered transcripts to store the filtered and sorted results. There is search query to store the user's search input. There is sort by to control sorting order. And there is deleting it to track which transcript is being deleted. When the page loads, a use effect runs to initialize the data. It fetches the session and transcript history in parallel. If successful, it stores the transcripts and sets the filtered list to match. After that, loading is set to false so the UI can render. Another use effect runs whenever transcripts, search query, or sort by changes. It filters transcripts based on file name, text, or language matching the search query. Then it sorts the filtered results based on the selected sorting option, either newest, oldest, or file name. Finally, it updates the filtered transcript state. There is a handle delete function that runs when the user deletes a transcript. It stops the click from bubbling up. It shows a confirmation dialog. It sets the deleting state. It calls the delete transcript server action. It removes the transcript from the list if the call succeeds. There is also a handle copy function that copies transcript text to the clipboard when triggered. If the page is still loading, a spinner is displayed in the center with a loading message. When loading finishes, the main layout appears for the user. It is wrapped with auth checks to allow only signed-in users. At the top, there is a header section showing the title transcript history and a description with the number of items. There is also a button that allows the user to navigate to create a new transcription. Below that, there is a controls bar inside a card. It includes a search input field for filtering transcripts and a drop-down menu for selecting the sorting method. In the main content area, if there are no transcripts, a placeholder card is shown. It shows a helpful message based on the current situation. It checks if the user is searching or has no history. It also shows buttons to clear the search. It offers a button to create a new transcript. If transcripts exist, they are displayed in a list of cards. Each card shows a preview of the transcript text, the date, the language, and the file name. Each item also includes buttons for copying the text and deleting the transcript. If a transcript is being deleted, a loading spinner replaces the delete icon. At the bottom, if there are many transcripts, a Load More button is displayed for future pagination support. This page helps users search, sort, view, copy, and delete their transcripts. It keeps everything clear, simple, and pleasant to use. Now let's check our application. As you can see, our full transcript history appears here. Every transcript we created so far is listed. We also have a copy button for the text. We also have a delete icon for removing the transcript. Let's search for something here. For example, I type the word model into the search bar. As you can see, these two transcripts include the word model. The search feature works correctly here. It finds the matching transcripts instantly. Let's test the drop-down menu. As you can see, it's working fine. Let's delete one of them. For example, this middle one. Okay, the deleting is working fine as well. So that was it for creating the transcript history. Let's add this one to the GitHub. In the next section, we're going to complete the dashboard page. So see you in the next section. All right, in the last section, we have completed the transcript history page. In this section, we're going to work on the dashboard page. We have already created this page. We need to just complete it. Let's go back to Visual Studio Code, and we go to the page.tsx, which is related to the dashboard page. And let's update the code. This file is the dashboard page that gives the user an overview of their speech to text activity and statistics. At the top, this file runs on the client side. It imports everything the dashboard needs. That includes auth wrappers, icons, React hooks, and server actions. It also pulls in UI components and navigation helpers. It also sets up a user stats interface. It tracks total transcripts created. It tracks transcripts made this month. It tracks transcripts made this week. It also tracks the number of unique languages used. Inside the main dashboard component, we define several pieces of state. We use loading to track the current loading status. We use transcripts to store the user's transcription history list. We use user stats to store the calculated statistics. We also use user to store basic user information. A router is also initialized for navigation between pages. When the page loads, a useEffect runs the initialize dashboard function. It fetches the user session and transcript history in parallel. If user data is available, it is stored in state, and if transcripts are successfully retrieved, they are also stored. The code also calculates helpful stats from these transcripts. It counts the total number of transcripts. It checks how many were created this month. It checks how many were created in the last week. It also counts how many different languages were used. These values are saved in the user stats state, and loading is then set to false so the UI can render. If the page is still loading, a centered spinner and message are displayed to indicate that the dashboard is being prepared. Once loading is complete, the page is wrapped with authentication components to ensure only signed-in users can access it. At the top, a header greets the user by name. It also shows a brief description of the dashboard. Below that, a grid of statistic cards is displayed. These cards highlight your total transcripts. They also show how many you created this month. You can see how many languages you have used. You also see the date you joined. Each card has its own icon and style. Next, there is a quick action section that provides two main buttons. One button takes you to create a new transcription. The other button opens your histories, where you can review past transcripts. After that, there is a recent transcripts section. If no transcripts exist, a friendly message appears. It invites the user to create a first transcription. A clear button also appears and leads to the creation page. If transcripts do exist, the most recent 5 are displayed in a list format. Each item displays the file name, language, and date. It also shows a short text preview and a copy button. There is also a button to view all transcripts, which navigates to the full history page. This page gives a clear view of the user's activity. It brings together key stats, quick actions, and recent transcripts. It all appears in one clean and easy-to-use dashboard. Now, let's check the website. You can see the dashboard now shows a total of 2 transcripts. This matches our data exactly. You can also see how many different languages were used. For example, we have 2 languages, including English and Spanish. We see our recent transcripts here. And there is a button to go see the history, and also we see the time that this user is joined here. All right, that was it for creating the dashboard page. Let's add this one to the GitHub. In the next section, we're going to work on the home page of our application before deploying our apps to Vercel. Let's begin creating the home page for our project. First, we need to create a component for the demo section. Go ahead and open Visual Studio Code, then navigate to the Components folder. Inside this folder, we will create a new file called demo section tsx. This file defines the demo section of the homepage, which showcases real-world examples of how the speech-to-text feature can be used. At the top, the code imports UI components such as buttons and cards, along with icons and navigation tools. Inside this demo section component, we define an array named examples. It lists sample audio use cases like a team meeting. It also includes a podcast episode and an interview call. Each example includes a title, the source audio file name, a short excerpt of the transcribed text, and a tag that categorizes the audio type. The layout begins with a section that has a gradient background and proper spacing to visually separate it from other parts of the page. At the top of this section, you will see a centered heading. It invites users to explore what they can transcribe. Below it, a short description explains that these are real-world examples. Below that, the examples are displayed in a grid layout where each item is rendered as a card. Each card includes a header with an audio icon, the title of the example, and a tag label that indicates the category. Inside each card, a styled box shows the source file name. An icon appears next to it for quick recognition. A short snippet of the transcription appears below as a preview. At the bottom of each card, there is a small label that reinforces the category of the audio. After the grid, there is a centered call to action button that encourages users to try the feature themselves by navigating to the transcription creation page. This section gives a clear visual overview of supported audio content. It also shows the transcription quality users can expect. Now that we have completed the demo section file, we can complete our homepage. The homepage is already created and it's here inside this page.tsx file. So here, let's update this file and explain it line by line. This file defines the homepage of our application. It is the main marketing page for the speech-to-text platform. It also serves as the entry point for new users. At the top, the code imports buttons, cards, and helpful icons. It also brings in navigation helpers and the demo section component. Inside the homepage component, several arrays are defined to structure the content of the page, including features, testimonials, and pricing features. The features list shows the core strengths of the platform. It covers audio-to-text transcription and clear multi-language support. Users also get a saved transcript history for easy access. Fast GPU-powered processing keeps everything quick and responsive. Each feature includes its own icon, title, description, and styling. The testimonials array contains user reviews with names, roles, feedback, and ratings to build trust and credibility. The pricing features array lists the key features included in the free plan. The layout starts with a navigation bar fixed at the top. It shows the brand name and links to features, pricing, and reviews. It also includes buttons to sign in or try the product. Below that, you will see the hero section. It introduces the main value of the product. You will see a bold headline about turning speech into text. There is also a short and clear description. 2 call to action buttons invite users to try it. Another button lets users view examples of real usage. It also includes a trust section with key metrics such as number of processed audio files, active users, uptime, user rating, and availability to build credibility. After the hero section, a demo section is displayed to give users a preview of how the product works in practice. After the demo, the features section appears. It shows each feature in a clean card grid. Every card includes an icon, a clear title, and a short description. This layout helps explain the product's main strength. Following that is the How It Works section, which explains the process in 3 simple steps: uploading audio, choosing a language, and transcribing and saving the result. Each step is visually structured to make the process feel simple and intuitive. Next is the testimonial section with user reviews shown as cards. Each card displays star ratings, feedback text, and clear user details. After that, users see the pricing section with a free plan. It clearly shows a price of $0 with listed features. A bold call to action invites users to start without a credit card. The section emphasizes ease of entry and value. Next comes a call to action section that invites users to begin. It offers buttons to try the platform free. Another button opens the dashboard for returning users. This section strongly supports the main conversion goal. The footer wraps things up with extra navigation links. It includes product pages and support options. It also shows a short description of the platform. A clear copyright notice appears at the bottom. This page gently leads visitors from interest to taking action. It shows the product's value in a clear, friendly way. It highlights key features, real feedback, and simple pricing options. It also points to clear next steps with strong prompts. All right, now let's check our application. Let's go back to the final version and we go to the home page. As you can see, every section appears here. It matches exactly what we coded. So let's get finished this application and add it to the GitHub here. Let's create a message. So that was it for creating our application. In the next section, we're going to deploy our application to Vercel platform. So see you in the next section. All right, in the last section, we have completed our application by completing the home page. In this section, we're going to deploy our application to Vercel. Head over to vercel.com in your browser. Make sure you are logged into your account. The platform is completely free to use. You can create as many projects as you want. Here you need to click the Add New button. After that, choose Project from the list. Here you see your list of GitHub repository. If it does not appear, connect your GitHub account to Vercel. As you can see, my latest project is listed here. We can just click on Import to import the project. Here we need to choose the front end of our application. So we're going to edit this root directory and choose the front end. Next, we need to set up our environment variables. So let's go back to Visual Studio Code and we go to our .env file inside the front end folder. We're going to copy everything and paste it inside this environment variables. Later, we will update this better auth URL. It must point to the final deployed version. But now we just leave it as localhost 3000. So we're going to click on deploy. This deployment step will take a short moment. Expect it to run for about 1 to 2 minutes. If something goes wrong, the error message will appear right here. Now they are installing the dependencies. I'm going to pause the video and come back when the deployment is completed. All right, so the deployment is completed. As you can see, the deployment completed successfully. This is the application domain we received for free from Vercel. Let's click on it and visit our application. Before we test the application, we need to update the base URL. We will change it inside the environment variable. So I'm going to copy this URL and let's go back to the setting. You go to environment variables. And here I'm going to update the better off URL here. Let's save this and redeploy the application. Let's check the deployment now. All right, the deployment is completed. Let's refresh our application. Let's create an account. It looks like we are running into an error here. Let's check the logs inside the application. Let's open the network and check the error. As you can see, we are hitting a CORS error. We need to fix this. We go back to auth.ts and add the trusted origin. We will redeploy the application. This update will include the new change. After we push this change, Vercel will deploy it automatically. So let's go back to our project, and we go to the deployments, and here we can see that the new deployment is started. All right, the deployment is completed. Let's check again our application. Let's refresh the page and try to sign up with a new account. Seems like we are getting the same error. I think we also need to update our Auth client configuration. I just removed this localhost entry. I will fix this config and import the env like this. Let us save these changes. After that, we will redeploy the application. Let us switch back to Vercel. We will check the latest deployment there. All right, the deployment is completed. Let's test it again. Let's go and sign up with a new account. This time it worked smoothly. You can see there is no error. Here, let's try the application. Let's upload a file here. For example, I will upload this sample file for the transcription. You can see everything working well. The transcription also finishes very quickly. That is the end of our project. I hope you enjoyed it and learned a lot. Please share what you think about this project. I would love to read your feedback. I look forward to seeing you in the next project.